Okay. Hello. Oh, also, because we're recording this, you might have to like turn off the speakers on your laptops. So, so that I don't have to mute. Okay. Hello, everyone. Thank you for coming. This is session 2 of Hackschool. Sorry for all the weird technical difficulties. We'll try to get it figured out by next session. So before we get started, we have like an announcement from Eugene.
Yeah, so as many of you probably know from the marketing pushes that we've done and ACM as a whole, the internship apps are out. So if you attended Hack Fall GM or ACM Fall GM, you probably know what this is. But this is the pipeline to get you to become a full-fledged officer like the people you see up here. As an intern, at least in Hack, you'll be doing almost what the officers do. You'll have a role and you'll contribute either to marketing or the curriculum development, or just creating all these workshops that we're giving you right now. The deadline for this is week 5 on Friday, so that's 2 weeks from now. But don't be a procrastinator like me and try and do it as soon as you can, just so you don't have that to worry about. So we would love for you guys to join the team. This is how you do it, so please apply. Thanks.
Great. Thank you. Okay, so just some more logistics. I keep looking there out of habit. This is well, much of this is similar from last week. So just a reminder that our Hackschool sessions are always at this time and this place. Keep a lookout for our Facebook events for any changes. And then this is a reminder to RSVP, or I guess that's, and also to fill out the symptom monitoring survey before you start. Can everyone hear me okay at the back? Yeah, okay, thank you. So just another overview on curriculum. This is week 3, and we're doing an introduction to JavaScript. These are the link to the slides. So if you need the slides or the README, to have them open during the workshop, just type this link and that'd be great. Okay. This is the membership portal attendance code. So if you are following along on the ACM membership portal, please type in the code. The code this week is I love JavaScript. And at the bottom here is the feedback form. If, well, there's going to be a lot of feedback, I assume, about the projector. But seriously, though, we really appreciated your feedback last week. And we hope that we can get some feedback from you at the end of this workshop. So if you would fill this form out at the end, that would be great too. Okay, so just another reminder from last week. For the course of this Hackschool series, you'll need a text editor and obviously Chrome. We recommend VS Code, although you probably won't be needing that this week. Okay, so let's get started with JavaScript. Today we'll be learning about the foundations and the fundamentals of JavaScript. But first of all, what is it? Well, it's a programming language, and it's often called the programming language of the web. And that's because every website that you see, every website that you go to, the browser that displays the website, underneath the hood is running JavaScript code. And, you know, before we learn about that, let's talk about why we're learning it. So for example, if we have a button, and as we learned last week, using HTML and CSS, so button, and you can style a button like this. And when you click it, sorry, is there someone who hasn't muted? Because I think I'm hearing. No problem. And then, yeah, so when you click the button, what do we want to do with the button, right? Like usually sometimes maybe we want to change the text from click this button to button clicked. And from last week, we haven't really learned any ways of doing that. And this week, we're gonna learn about JavaScript and how it can help us to do that. Okay, so a note on notes. While you're welcome to code along in your own browsers, we actually encourage you not to. Instead, to take notes on concepts that are new to you. And you can always refer to the README for all the code that we wrote later. So I'm actually going to go to our README. Let's see. Okay, it's here. It's on the link on the slide. So if you go to our README, this is the link to our README. It should be one of the links that we posted earlier. And this has everything that you'll need. So this is what I'll actually be going over for the entire session today. And if you don't need to worry about taking notes, because if you look back at the README, you'll have everything and more. Okay. So it's JavaScript time. First, how are we going to run our JavaScript code? We're going to run it using the console. So if, as I said just now, you remember that I said that browsers help us to run the JavaScript code whenever we load a web page. If you go on Chrome, so I'm on Chrome right now, and let's say you go to a new tab. If you right click onto the page, you'll see this inspect button. And if you click on inspect, this opens up the Chrome developer tools. And your screen, if you do it on your screen, it might look something like this. And then you'll see here, I'm going to zoom out a bit. You'll see here, you're on an Elements tab. And if you click on console, you'll see the console. Okay, and on this console, we can actually use it to run any JavaScript function or any JavaScript code that we want. And for easy, for us to see this easier, I'm going to dock the console on the side, so I could pop this out and you can display it like this. And yeah, that's great. Okay. Yeah, so if you want to like pop the console out like I did, you have to click on these 3 triple dots here. And then right now you should be hovered over this option on the right. If you want to do the same as me, you'll have to click the dock side here on the button on the left.
Spec element. The total looks fine. Just go to any site and then.
Oh, like opening the dev tools. Okay, so I can close this dev tool again. So on any web page, doesn't have to be the new tab. You can right click onto the page. So right click and you'll see inspect. And then you just click inspect and it'll open up the dev tools. Yeah. Okay. And then after you open the dev tools, you'll see that there are many different options. You'll want to go onto the console page, onto the console tab to be able to run any JavaScript code that we want. So, what can we run? So this is the console, and we can do any. For example, we can do 5 + 5. And when you press enter, you'll see that it prints out 10 for us. And you'll see that the console prompts us for another input. So, we could do more things like 1 + 2 or like 3 + 4. And one thing to note is that you can use the up arrow key. So right now I'm going to press the up arrow key and I'll go to the previous input that I just wrote. And this is because the console sort of remembers the lines that you've typed. So if I press the up arrow key again, I can go and I can navigate to the previous commands that I typed. And I could go for navigate using the up arrow key and the down arrow key to different commands. Okay. So this is the console. This is where we run our JavaScript code. A few features about the console is that shows the result and value before you press enter. And it also prints out whatever is the result of the code that you ran. And as I explained before, it remembers the previous lines that you've run. And you can also use the up key to find previous lines. Cool. So moving on, there is the console.log function. So in the console, we can use this console.log to print out whatever we want onto the console. So if we console.log hello, it prints out hello for us. Okay, and this is very similar to the print functions that you see in other programming languages. So if like cout or something like that, or print, then console.log is something very similar. So if we console.log like 4, just to give it 4 plus 3, just to give another example, then it will evaluate the expression and it will print it out onto the console. Any questions so far? Okay, yeah. The attendance code was I love JavaScript, like this. It up for a bit. Also, if make sure to mute when you join the meeting, just so it's like better for the recording. Thank you. Okay. Let me move on. So a note about semicolons. So you may have noticed that I appended a semicolon at the end of every expression. And an expression in JavaScript is exactly like what I typed. So like 5 plus 5, that's an expression. And I put a semicolon at the end of the expression. You can think of an expression as like a sentence in English. And then we always need a semicolon to end the sentence, just like you would use a full stop. And just another note about the semicolon is that in JavaScript, this is actually optional. So you can, for example, if I go back to my console, if I did 5 plus 5, this actually works like just like if I didn't have, or if I did have a semicolon. But generally, it's recommended to always use a semicolon because when you get to like more complicated code, you'll get certain behaviors that you may or may not want if you didn't have a semicolon. So it's always recommended to have a semicolon, and we will always be doing this for the rest of Hackschool too. Okay, so moving on to comments. So if you don't know what a comment is, it's basically like basically like what it means. It's a comment. It's not supposed to affect how your code runs. It's more of a way to annotate your code. And in JavaScript, there are 2 different ways to write comments. One is using the double slash for a single line comment, and for a multi-line comment is the slash followed by a star and then a closing star slash. So going back to my code, for example, if I did this is a comment, I'm going to zoom out a bit because we're not in person anymore. And so this is a single line comment. You'll see that if I copy and paste this onto the console, it does nothing because the comment is, it's supposed to do nothing in terms of code. It's more of like an annotation for our code. Similarly, for a multi-line comment, it starts with a star and a slash, and it ends with it starts with a slash and star, and it ends with a star and slash. And this is a multi-line comment, so I can, put as many lines as I want, and it will still be a comment. And same if we copy and paste this onto the console and press enter, it does nothing. It means nothing. So for example, if I did 5 plus 5, an example of how comments is used is I can write a single line comment here. This is 5 plus 5. It should equal 10. Cool. And when I execute it, you'll notice that, the console still gives us 10 back. Doesn't, the comment that I wrote doesn't really affect what happened. Okay. Okay, also another note about the console is there's a button up here called, like, it looks like a stop sign. If you click it, it actually clears the console, and it's very useful whenever the console gets clogged up. Or you could type Control L. Okay, oh, so that's comments. Moving on to basic types and values. So in JavaScript, there are several basic types of values we can use. Numbers, Booleans, and strings. You can think of these types as different categories of values, and we call them types. So first of all, if you're using numbers, numbers consist of any sort of numbers that you see in daily life and in maths. So these include, whole numbers or integers, decimals, negative numbers, and even scientific notation. And we can also perform operations on these numbers. So just like we can do arithmetic operations like plus, minus, multiply, and divide, we can do these in JavaScript too. And that is using these symbols here. And other operations that we can do is using the comparison operation. So this is the triple equal sign tests for equality. It sees if two numbers are equal. The exclamation mark followed by two equal signs is for inequality. And these ones over here are pretty as well. Okay, so let's see some examples of this. Actually, we've already seen some of the numbers before. So 5.3. We can add them together, 4.2, and it gives us the addition if we use the addition. Other examples. We can move on. We can do equality. So we can check if 35 triple equals to 35, and this just sees if, well, the number on the left is equal to the number on the right, and in this case you'll see that this is true. And if we gave it something not true, so for example 35, is it equal to 12? Well, 35 is not equal to 12, so the triple equals operator gives us false. And this is similar for the inequality. So is 35 not equal to 35? No, right? 35 is equal to 35, so it's false. And is 35 not equal to 12? That's true. If any of you are taking CS31 or have done other programming before, not in JavaScript, you might be more familiar with like the double equal sign in C++ or Python. And in JavaScript, the double equals and the exclamation mark equals do slightly different things compared to other programming languages. And in JavaScript, we generally always want to use a triple equal sign and the not triple equals and the exclamation mark followed by two equal signs. So that the behavior of these symbols are the closest to what we want in C++, like as in C++ and Python. So that's just a note. Moving on, Booleans. Booleans can have two possible values only, true or false. So, for example, we've seen it in our previous example, was 5 equal to 5, and it gave us a Boolean back. It was true. Now for operations on Booleans, we can do 3 different operations. One is the logical and, the logical or, and the logical not sign. And these logical operators actually work very similar to English. So for example, if you have 2 Booleans, A and B, A and B is only true if A and B are true. Similar for A or B. A or B is true only if either one of A or B is true. And for not A, it is simply, well, A but flipped. And the only other flipped value from true is false, or for false to true. And this is like a on here is like a truth table for all of the different operations. And we can look at some of these. So we can look at some of the examples. So for example, I'm going to clear the console. We can have, not true, and it gives us false back because we simply flipped true to false. For and, we can do true and true. And you notice that true and true is true, right? But if true and false, that's false, because for the and operator to return true, both sides must be true. For or, oh, by the way, for or, for those who don't know, it's like there's two of the pipe operators, as we call these the pipe symbol. And if you want to get it on your keyboard, it's like shift plus this key on your keyboard. Okay, so for or, we have true. If we have true or false, then it gives us true. Similarly, false or true is also true. But if you have false or false, that's false. And you could combine and match these. For example, true and false, or true and not false. And then you'll see that, it returns to us true. So, just as an exercise to you guys, what is true and false, or false or true and true? Let me see if I made a typo. Okay, let's not. Okay, try not to run this on your console. Does anyone know what it's going to evaluate to? You could also discuss it with the person next to you if you don't know. Does anyone have an answer? False? Okay, let's try to run our code. Okay, so if we press, okay, it's already given us the answer here, but it's actually true. So if we see here, let's break this down one by one. So true, this first one here is simply true and false. And we know that for the and operator, it's only true if both sides are true. So this has to be false. This is false. Or with this thing on the right, okay? So what is this thing on the right? Well, it's not, let's look at what's inside first. So not false, that is true, or true. So not true or true is true. So this becomes true and true. And then if you look at the expression on the right now, it becomes false or true, because if for the and operator, if both sides are true, then it evaluates in the truth. And then we have false or true. And for the or operator, if either one of them is true, then the entire expression is true. So it's true. Does that still does it make sense for anyone? For everybody? Is there any more questions? Good. Okay. Wait, by the way, you guys can see my screen, right? Yeah, I just see you guys are looking at me. I'm like, shouldn't they be looking at the slides instead? It's okay. Okay, moving on. Strings. So this is the last major basic types that JavaScript provides us. And a string is just a sequence of characters surrounded by quotes. So for example, quote 1, 2, 3, 4, 5, quote below. we can use these sequence of characters to form text. And we can use this text in many different ways. One note in JavaScript is that in certain languages, not JavaScript, the single quotes and double quotes have different meanings to them. But in JavaScript, they mean the same. You can make a string with a single quote or a double quote as well. And let's see some examples. So for example, if I clear my console, I can do hello. And it returns to me hello. Similarly, I can use a single quote, hello, and it's exactly the same, but you can't mix and match. So as I just demonstrated just now, you can't mix and match, but then you can use either of them. It's up to you. Okay. Some other things that you can do with strings is that strings can be concatenated using the plus operator. And by concatenated, we mean that they can be joined together. So from the example on the top, hello plus world is just hello world. And strings can be concatenated in any different combination you like. Strings can also be compared to each other. So the equality and the non-equality operators that we covered before for numbers also apply to strings. So on the left, hello is obviously not equal to world, but so this is going to evaluate to false. But on the right, hi is equal to hi, even though they have different, even though they have one is using a double quote and the other is using a single quote, it is all equal. Okay, so let's see some examples of this. So let's define some strings. My favorite anime is, and then I can use the plus operator to concatenate the strings, and Naruto. Yeah, hey, let's go. Yeah, and what is printed out is the joined version of both strings. Yeah, that's it for examples. Okay. Right, for now, I have some exercises for you guys. So what will get printed in each of these questions? Try to figure it out without actually running the code. So take like maybe 5 minutes to think about it, discuss with the person next to you, and then we'll come back and like review the answers. I'm gonna make this, maybe this is easier. Yeah, cool. If anyone wants me to like zoom in, make the screen bigger, just shout. My favorite character, okay, it used to be Kakashi, but I changed. I'm on the Itachi ship now.
Exactly.
Yeah.
Everyone goes to Itachi.
Yeah, no. So sad, so sad.
This is such a good story.
Yeah. Okay. Does anyone have suggestions on what the answers are? So let's go for the first one. Console.log 1 plus 11. What's it gonna print? 12? Good, good. What about the second one? 111? Yeah. What about hello or not equals to hello? True. True. Okay. So this is actually true. Good. And for 5 triple equals to 8, false. What about console.log not true? False. And what about this expression, the last expression? Okay, let's try run all of them to see if you guys are right. So I'm going to copy and paste this, and then I'm going to paste it in my console. Yeah, I think you guys got it all right. Oh, also, another thing I forgot to mention is that if you want to do multi-line stuff, so for example, in the console, let's say we console.log something, and then I want to write another line of code before I start executing, you have to hold shift and press enter, and then you go to the next line, and then you can keep typing. Okay, yeah. All right, let's move on. So what if we want to store some values to use later on? We can do this using variable. So how do we declare variables in JavaScript? We can declare them two ways. So the first way is using the let keyword, and this is used for variables that can change in value. So on the left here, we see let x equals to 5. The second way is to use the const keyword. So, and this is used for constants, values that you don't want to change afterwards. So for example, here we define const pi equals this decimal, and we don't want it to change afterwards. Yeah, and let's see some examples of this. So one way, as we saw, the first way we can do define variables is to let name equals to Alex, and if you press enter, we've declared the variable, and then we can use this variable however we want later. So we can console.log it. So if we console.log name, we print name, and it prints my name. Another thing you can do with these variables is you can rename them. So name equals to, let's say, Eric, who is not here today. And it changes this name's variable value to Eric. And if we console.log it again, you'll see that it's now Eric. For constants, for example, if I did const pi equals to 3.14, you'll see that I can't change it later. So let's say I try to redefine pi into 3.1415. JavaScript doesn't actually let me. It just throws an error because I tried to change the value of a constant. So that's something to know. Usually constants you will want to use it for things that aren't going to change and you don't want to change. Okay. Yeah, we have some examples. I have some easy problems here, but I'm gonna skip it in the interest of time. And we can move on to functions. Before that, does anyone have any questions? Good. Okay. So let's talk about functions and why we want to use functions. So let's say that I really like anime and I want to tell the whole world what anime I like. So here I console.log the bunch of statements saying that I really like all of these anime, and you get the idea. But what if I want to change I really like to, I really like, or I love Naruto, I love Demon Slayer. Then I would have to go back into my code and change all of the I really like to I love. And that's the total pain, right? So functions, I forgot about this slide. Functions can help us solve that. Functions are used to perform a certain action, and that's very vague, but hopefully some examples can help clear that up. Functions can have arguments, or they can have inputs, and then they can output something. So functions take in some input and then they output something, and we say that it returns a value. And then finally, an important thing to note is that we assign functions to variables. Okay, so let's look at how it's done. So there are two ways to declare functions in JavaScript. One is using this method up here. And the second is using the method down here, using the function keyword, and the other is using what we call the arrow syntax. So the top one is we usually call it the arrow syntax. This bottom one is called we usually call it the function keyword. And we will be using the first way. Yeah, for like the rest of Hackschool will be using the first method. Any questions about this? Cool. Okay, so let's dive into what this actually, like, let's break down what the syntax for this looks like. On the left here, we'll see that we just simply declared a constant named my function, and then we're assigning this to something. We're assigning something to my function. And this is, so you'll know that, you know from this is that everything from now on is our function, is part of our function definition. So on between the parentheses, we have arg1 and arg2. So this is where we specify the arguments of the function or the inputs. And then you'll see an arrow, the arrow. And I like to think of this arrow as like it goes to. So we have inputs, and then this goes to our output, or it does something with it. And in between the curly braces, or the braces, is everything that our function does. So we have input. Remember, just to reiterate again, we have input here, and it goes to, or it does something in our function, and it does something, and it does an action, right? So this is how we define a function. Let's see how we can use it. So for example, let me clear the console. Let's say that I wanted to write a function named hello world. So that just simply prints out hello world. Okay, so I can do const, and I'll name this function hello world. And similar to the previous slide, we can do equals, and we're assigning it to a function. This function, hello world function, takes no arguments, so there's no inputs. It's simply an empty parentheses. And then we want to do an arrow. So this empty parentheses, it goes to something, right? And remember to have the curly braces. What does it do? What does our function do? It just simply console.logs hello world. Okay. And enter. Okay. So we've defined our function. And to call our function, we just simply do hello world with the empty braces, with the parentheses, sorry. And if we press enter, we see that, yeah, indeed, this code inside of the braces was run, and we printed console.log hello world. Okay, I'm gonna do the rest of the examples in here, so it's easier to type. Okay, so let's write another function. Let's write a function called hello name. So if we write hello name, and we just want to say hello to whatever name that we pass in. So we can do name. So this is one of our arguments. And all we want to do is just console.log hello plus name, right? So, oh yeah, and I forgot the arrow. So what you see here is an example of how we can use arguments. So we pass in name as an input to our function, and then we can use this input inside here. And if I copy and paste this back into the console and I run it, cool, we've defined our function. And now to use it, for example, I can just go hello name, and then I pass in someone's name. So for example, my name, Alex. So I'm saying hi to myself. I have no friends. Hello, Alex. Great. So it printed hello, Alex. Great. Okay. Some other examples. Let's try to write a function named triple that triples a numeric input. So for example, I will write a function named triple equals to x, some number x, and this simply goes to x times 3. Okay. If I paste this, if I define this, and I call it with like for triple 3, you'll see that nothing happened, right? But why, right? We console sorry, in our function, we definitely multiplied x by 3, but why did nothing happen? And that's because we never returned our answer. So you can use this return keyword. So we can use the return keyword to actually return anything that we calculated inside of our function. So for example, if I find a new function, triple with return, and same thing, it takes in a number x as an input, and it goes to, and we simply return x times 3. And if we paste this into our console, and then we call this new triple with return with 3 now, you'll see that now, okay, because we returned the value, we can, the console is able to display 9. Yeah.
So then what is it doing before the return? It's just like ignoring
No, well, sort of. What happened before was that in the original triple function, all we did was multiply the x by 3, and we just multiplied it, but we never explicitly tell JavaScript to actually display it or give it back to us in some form. And in this case, we can, because we returned it, you can think of this return as the function's output, and then we can assign this output to something else. So for example, we can do let tripled 3 equals to triple with return, and then we can do 3. And if we console.log 3, sorry, triple 3. Oh, triple 3. Sorry, I made a typo. It gives us 9. So yeah. Any other questions? Cool. All right. So, I've defined I've talked about some functions and all that. Let's do some coding questions. And the first of the problems that I want everyone to have a look at is this one. So what gets printed? I'll just take some time to look at this code here. What gets printed if we run console.log YOP3 here? YOP 523. Yup. Feel free to discuss with the person next to you or think about it for some time, and then we'll come back with the answer. Oh, and try not to run the code or look at the answers. Yeah.
So the functions just auto to whatever the path
Yeah. Sort of not auto casting. It's just using the variable as it is. It just has a type, and if you try to do something, so if you pass in, like, let's say a number in it, and inside your function you try to add something to the number, another number to the number, that works, right? Because you're adding a number to a number. But if you passed in something weird in that doesn't let it, then it just throws an error. It just gives you an error. So it tries to run it. If you provide it with bad input, let's say, and it tries to run it, it will always try to run it. And if it runs into an error, then it will just throw the error. It'll just give you an error. But it won't like scream at you if not like C++, it won't scream at you for any like statically, or sorry, I shouldn't have used that word, but like it won't, like when you press compile, it won't like scream at you or anything. Yeah. Yeah, so you could, it's not like casting because
sorry on that. I think what else?
templates.
Yeah, the function.
Mm,
That's
that's a little different because the way it works for at least for function templates is that, well, what you're talking about C++, right? Under the hood, C++, when you define the template for, it will generate the code for every single, so say you had a template and then it was like, you have a template and it generates a code for if the template was an integer or if it was a string.
Generates those.
Yeah, but then yeah. And for JavaScript, it just runs it.
Right.
Yeah,
Not really.
yeah, it's very different languages. Okay, so does anyone have an answer? Yeah. 9, correct. Let's actually just run it just to check. If we run the code, 9, yay. Okay, second one. What gets printed out here? Okay, does anyone have any suggestions of the answer? Or yeah, at the back. Uh-huh. And are they all on the same line? Yeah, that's right. So if we ran the code, it just bread on one line and then jam exclamation marks on the other line. Does anyone need an explanation of why? Okay, cool. So these are some, like, we've seen some examples of how, functions can be defined. Let's do something more interesting. Let's have you guys code now. Let's write a function called anime planner that has 2 arguments. One is total hours, how many hours I can spend on watching anime today. And the other is current minutes, the number of minutes I've already watched anime today. The function should print out how many episodes of anime I can still watch today. And fractions of episodes is fine too. And each episode of anime is 20 minutes. And let's take maybe 10 minutes, 15 minutes to do this. Yeah. And while I'm doing that, I can walk around to see if anyone needs help. actually. Wait, let me see. Yeah, this is way better. Wait. Yeah, this is way better. Okay, cool.
Unfortunately. It's okay.
Still having some. Okay. My gosh. Okay. Okay. Let's bring it back in. Okay. So even if you didn't get it, or if you did get it, I'm gonna go over how. Well, I did it. So this is one of the valid answers. There are probably a lot of different ways to do it. So if the way you did it doesn't look exactly like this, that's fine too. But yeah, let's get into how we would begin to code our anime planner. So first, we need to define, well, the function. So we define const anime planner equals to, it takes in the total number of hours that I can watch anime a day, which is total hours. and current minutes, which is the number of minutes that I've already watched anime today. Cool. And what should we do? Like, how do we calculate it? Well, first of all, we need to convert the total number of hours into minutes, because we need to get because both of our inputs have different units right now. We should get them to the same number of units. So I'm going to define a variable called total minutes, and this is simply total hours. So the total number of hours I can watch anime, but in minutes. So total hours times 60. Now that we are using the same units, I know that the remaining amount of time, the remaining amount of minutes that I can watch anime for is simply total minutes minus current minutes. I can't see what is going on. Okay. Okay, and we are going to define a let's call this new number remaining minutes. Okay, so it's kind of hard to see actually, so let me just try to zoom out a bit. Yeah, okay, cool. And this is the number of minutes that we have, but notice that like we need to know what this minutes, how many episodes we can watch with this minute. So we just do can watch, and that is simply because there are 20 minutes in an episode, we just do remaining minutes divided by 20, and then that's the number of episodes that we can watch. So we can do console.log you can watch plus can watch episodes. And if we paste this into our console like this, and we enter, you know that we've defined, this looks a little weird because the line is too long, so it just fits everything onto another line. But now if we call our anime planner with the arguments, let's say that I can only watch 2 hours a day, and I've already watched 40 minutes, or let's give it more awkward time, 30 minutes. I can watch 4.5 more episodes of anime. Great. Okay, so after this exercise, we are going to jump into break. So I know we've been at this for like an hour already, so please use this opportunity to you know, get some rest, good toilet, drink some water. We'll come back at, let's say 5 minutes, so 17. Yeah. I mean, if you want to follow along, there's always the README, and then there's also a recording. There should be a recording.
And also, sorry. Oh, and on the recording is the group, like the bathroom.
Cool. Okay, so next we're gonna talk about conditionals. In programming, conditionals are used as a tool to define branching paths in code. So, you know, let's say that you can think of this as like a decision making based on some sort of condition. So, for example, if I wanted to watch anime now, it would depend on if I had an exam later. So if I had an exam later, I wouldn't watch anime. But if I didn't, then I would. So, yeah. Let's take this concept and see how it's applied in code. So for conditionals, there is the simple if statement. So if some condition is true, then inside the braces, we define the actions as if it was true. Yeah, and here condition refers just to some Boolean, true or false value. So any expression would evaluate into a Boolean can be the condition. And like, let's see some examples of this. So let's see. I thought I switched screen. Oops. Let's clear the console. So we can have a const. Let's first define a const greeting. Yeah. And let's say hi. And if our greeting is equal to hi, oh sorry, triple equal, then we can do something. Let's say because we want to greet, and then we can just say hello. Okay, and notice that because greeting is equal to hi, so we will execute the code inside, and we will say console.log hello. On the reverse, if it was not equal to hi, so let's say if greeting was equal to hello, this will not print anything because the condition is false. So we don't do anything. We don't run the code inside. Okay, the second form is the if else. So the difference with this is that we also specify what to do if the condition was false. And in this case, it just looks like an else statement, and then we have the braces. And then inside, we can specify what actions we want to do if the condition was false. So let's see some more examples of this. So I'm going to do it here actually. So let's say that we have test score equal to, let's say we took a test and we got a 50. If our test score was larger than 60, then we passed, okay? But else, if our test score is not larger than 60, then we failed. And don't fail your tests, guys. That's very important. Okay, unless there are, of course, more important things to do, like Hackschool. Okay, so let's try to run our code. Yeah, we failed. Why? Because our test score is 50, and 50 is not larger than 60, so we failed the condition, and so we executed the code inside of the else block, so we failed. Okay, on the reverse, if we change test score to 80, and we ran the code here again, then we would pass because 80 is larger than 60. Okay, any questions? Cool. Okay, moving on. The last form, the final form of the if else is the if else if else if else chain. And this sort of looks like a ladder, and it just lets you specify more conditions that you want to check for. And let's again see what this looks like. So let's say instead of just checking for if we passed or not, we want to know if what letter grade we got. So if test score is larger than or equal to 90, then we want to say that you got an A. Amazing, you got an A. Else if our test score is larger than 80, then we say that, you know, you got a B. Else if our test score larger than or equal to 70, then we got a C. Sorry, I have a typo here. You got a C, okay? And anything lower than a C at UCLA, I believe, is a fail. I think. Well, anyway, so console.log, you failed, unfortunately. And this is our else case, okay? So as you can see, it sort of looks like a ladder. That's why we call it like the conditional ladder. And if we run this code, you'll see that we got a B, all right? And this, notice that our ladder only checks for each condition, and if one condition passes, it will run the code inside and then it will exit the ladder completely. So for example, what happened here was that first it checked if test score was larger than or equal to 80. Just a reminder, our test score is 80. So we check if our test score is larger than or equal to 90, and that is obviously not true. So it goes and tries to check for the second condition, test score larger than or equal to 80. And in this case, this is true. So we immediately run the code here. So we run console.log, you gotta be. And that's why we say you gotta be here. But after it runs the code, it immediately leaves and doesn't do anything afterwards. It doesn't check for this condition, nor does it try to execute this. And that is because of the else if. All right. If we let's say I copy and pasted this code on the left down here, and I replaced everything with an if. Right, what would happen? Wait, no, let's just have else. Does anyone know what would happen if we tried to run this code? Yeah. Yeah, that's right. So if we run this code, it prints you got a B and you got a C. And the reason why is because there is no else if, there's only the if. And in this case, it will keep checking for all of the conditions. So even after it prints you got a B, it will go to the next if statement and check the condition. But if you have an else if, then it won't, and it will directly exit. So yeah, that is if else. Yeah, we've seen examples of this, and let's go do some more coding question. Yay. So this is the check masks function. I'm gonna see if I can. So you work for the new gym at UCLA, Bruin Gym, or B Gym for short. You're in charge of walking around the gym periodically and checking to see if students are wearing their mask properly in the gym. At any time, if you observe that less than 80% of people are not wearing masks, you are required to do an announcement on the PA system. For this exercise, write a function called check masks that takes in 3 arguments. The first argument is the total people. How many people are in the gym currently? The second argument is mask count. How many people are currently wearing masks? And the third argument is just an announcement, some message string that tells people to wear their masks. So what your function needs to do is if there are more than or equal to 80% of people wearing masks, your function, there's a typo here, should print nothing and return false. If there are less than 80% of people wearing masks, your function should print the announcement string and then return true. So yeah, so let's give another 10 minutes to try to do this question. Or yeah, 5 to 10 minutes, I guess. This shouldn't take too long, so maybe 5 minutes. And again, if you need help, just raise your hand. Okay, it's been 5 minutes. Hopefully you've had some time to try to do the problem. Let's go over the answers or how to do it. Where should we do it? Okay, on the left here. All right, so first of all, we need to write a function, check masks, that takes in 3 arguments: total people, mask count, and the last one was it, announcement. Oh no, I'm gonna run out a lot of space. All right, and our function needs to check if there are more than 80% of people in the gym wearing masks. So first we need to see if, and this is our condition. What is our condition? If more than 80% of people are wearing masks. So if mask count divided by total people larger than or equal to 0.8. And if that is true, that means more than 80% of people are wearing their masks. So in that case, we just return false. But if there are less than 80% of people wearing the mask, we need to use an else statement. In this case, we need to console.log our announcement, and then as specified, and then we return true. And yeah, so if we copy and paste this function into the console, and then let's say we run check masks, we can run, let's say there are 60 people, and then in the gym, only 40 of them are wearing masks. Gasp. And then our message is, all Bruins, please wear your masks. Okay, and if we run this function, you'll see that because there are less than 80% of people, our code prints the announcement and then a return true. Any questions? Cool. Okay, let's move on. We are running low on time. Moving on to objects. So far, we've only dealt with individual values, right? So for example, let's say I wanted to store my friend's information. I would say let name equals to Joe Bruin, and then let age equals to 18, right? What happens if I want to store another set of related data, right? So it'll be kind of messy. So I'll have to do let name 1 equals Joe Bruin, let age 1 equals to 18, and then I'll have to do name 2 and age 2. That's kind of not it, right? What if we had like a lot of different people? Then that'd be a lot of unnecessary typing. So what we can use to solve this problem is using JavaScript objects. So this is what a JavaScript object looks like. You'll see that it is denoted with these like curly, the braces notation. So if you see in the future, if you see that there's a curly braces, you'll know that this is a JavaScript object. And let's break down what's inside, right? So objects in JavaScript are store data in the form of key value pairs. So on the left here, you'll see that these are the key or the property. So and the key is simply like the name of the property. So as you can see in this example, a person has a name property and an age property. And then this is followed by a colon. And then on the right here, we have the values corresponding to those properties. So this person, and this becomes very self-explanatory to read. So this person, we define a person constant. This person's name is Joe Bruin, and this person's age is 18. Okay. Any questions about this? Okay, cool. So how do we access an object's properties, right? So we defined a person, and we want to access that person's name. And we can do this using 2 ways. One of these is the dot notation. So we can we can access our Joe Bruin's name using person.name, right? And as same as the previous example. So when we console.log my name, it prints out Joe Bruin. The second method is using bracket notation. And its form is that it has the object's name, and then it has these square brackets, and then in quotes, you have the property name. So similar to the previous example, if we wanted Joe Bruin's name, we simply do person, square bracket, and then in quotation marks name, and then we assign that to my name. And when we print it out, it prints out Joe Bruin, same as before. Any questions? Cool. Modifying object properties. So same as before, we can actually modify, well, not same as before, but we can modify the object properties using that same dot notation. So let's say I wanted to change Joe Bruin's name to Josie Bruin. We simply do person.name equals to Josie Bruin. And this is exactly like how we would change just another variable. But in this case, we're changing a property, the value of the property inside of the object. And similarly, you can do the same using the bracket notation. So in this case, I'm changing Josie Bruin's age from 18 to 19. And I'm doing this simply by using the bracket notation with person, bracket, and then in quotation marks age. And we assign this new, we assign the value of this property to 19. And you can do this the same to add new properties. And I'll show that later. So yeah, so these are some examples. Okay, so let's look at some examples. So, what should we do? So let's say that we had, you're applying to a job, or like you're accepting applications from applicants. So you have a const applicant, and you want to group all of this applicant's data together, right? So this is the most basic form of object. We have const applicant, and then we have these braces notation, right? So let's define some data. Okay, so this applicant, first of all, applicant has a name, say Alex, and we have, after every key value pair, you need a comma. I forgot to mention this before, but you need a comma, and then you have the next property. So email, abc@gmail.com, right? That's my email. Don't email me on this email address though. And then I also have maybe, let's say, a GPA. And my GPA is, for example, 3.0. Okay, so I guess I also forgot to mention this before, but for the value type, there is these values can store many different types. So you can store strings, you can store numbers, you can store functions, you could even store other objects inside. And yeah, this is sort of like the power of JavaScript objects. They're very versatile and you can do many things with them. Okay, so let's go ahead and paste this example in the console. Okay, so we've defined it. Let's try to access some of the properties inside of applicant. So we can do using the dot notation, so applicant.name. And same as seen, like exactly the same as shown in the slides, it's just Alex. We can also use the bracket notation. So let's say we did applicant, and then we use the square brackets, and then whatever property inside. So in brackets, so we do, let's say, email. And then this is just abc@gmail.com. Okay. What if we wanted to modify applicant's name? So I changed my name. I changed my name to Eric. Let's use the same example. So if I change my name to Eric now, if I console.log the entire object, you'll see that it now is an object where name is Eric, GPA is 3, and email is abc@gmail.com. Okay. Yeah, this is a cool thing about the console. You can just print the entire object. Okay. How about adding properties, right? Let's say each applicant needs a rejected or an accepted status. So for example, I could set a new attribute, applicant.rejected equals to true, okay, because I got rejected. Oh no, or Eric got rejected, never mind. So now if we console.log applicant now, you'll see that applicant now has an extra property. Email, GPA name, and now a new rejected property. And we can do, and this is how you add new properties to objects. Similarly, if we want to delete, similarly, if we want to add properties using the bracket notation, you do you do the exact same thing. So we can change up applicant, and then let's say we wanted to add address equals to, I believe Eric lives in Sproul, so we can do Sproul Hall. Okay, and this is how we add addresses like that. So if we do console.log applicant now, you'll see that yes, we added a new property with address, whose address is now Sproul Hall. Okay. Another thing about let's say you accidentally added a property that you didn't want to add. So for example, I accidentally added applicant dot password, and we didn't want to access the password, so ABC. If you wanted to get rid of this, we just do delete applicant dot password. Oh, let's show it first. So if we see console.log applicant, you'll see that right now our object has address, email, GPA name, and password. We have this password thing, and we don't want this here. Okay, we don't want this, so we do delete applicant dot password. And if we console.log the same thing again, you'll see that password has been deleted. We just simply removed it. And that's the basics of objects. Any questions? No? Okay. Well, I'm gonna skip over object methods for now. I want to do some more coding questions. Yeah, so let's do another coding question over here now that we've gotten more to get you more familiar with objects. So I think this is not the one. Okay, this is the one. Okay, so in a multiplayer video game, each player has an object like so. So let's say you're player 10 and your username, you have a username, you have a health, you have armor. And then you have another player, let's say Eugene. Eugene this is his username, and he only has 2 health and 0 armor. Okay. At any point in time, our game wants to know who currently has the highest health and armor combined. So because health and armor is directly proportional to skill. For example, since Eugene has a combined health and armor of 2, he sucks. Okay. So as a part of this, we want to write a function, player comparison, that takes in 2 arguments. Player 1, a player object that looks exactly like this. And player 2, another player object that looks like this. Okay. And the function will return the username of whoever has the most health and armor combined. In the event that the health and armor combined are the same, we want this to return the string equal. Okay, so let's try to do this problem. I'm gonna zoom out a little bit so you guys can see it better. Again, this is probably going to be the last thing we do today, but just give this a try. And yeah. And we'll come back and review the answers at 8:50.
leave now.
Yeah, thanks for coming. Oh, yeah, remember to fill in the feedback form if you have time.
Okay.
Yeah, I'll check on the readme. Thank you. Okay. Okay, let's bring it back in. Hopefully you've had a try at the problem. So we have, for example, we have these two objects, player 10s and player Eugene. We want to compare who has higher health and armor. So let's write our function, player comparison. And let's just call them arbitrarily player 1 and player 2, or as seen in the prompts. And okay, so what does it do? Well, we need to compare if the combined health of player 1, health and armor of player 1 is larger than the combined health and armor of player 2. So this is just a simple let's define new objects, new variables for them. So let's just say health player 1 H health armor. And this is simply player 1 dot health plus player 2 dot armor if you're using the dot notation, right? And sorry, let's change this to player 1. And then for the second one, player 2 health armor. If you're using the bracket notation, it might look something like this: health plus player 2 armor. I made a typo here. There should be 2, and that should be 1. Okay. Yeah. And then now that we've got these two values, we just need to compare them. So if player 1 health armor is larger than player 2 health armor, then we just need to return player 1 dot username. Okay. Else, if player 1 health armor is less than player 2 health armor, then we need to return player 2's username because player 2 has a higher health armor. Okay, and this is the last case. So if one isn't larger than the other, then the only way that can happen is if both players' health and armor combined were equal. And in that case, we just simply return equal. Okay, and this should be it for our function, unless I made any mistakes. So let's clear the console, and then we can redefine these again. Cool. And then let's say that we wanted to compare player 10s and player Eugene. So I'm going to paste these into my console as well and press enter. So now if I call player comparison, player 10s, player Eugene, then the obvious answer is 10s because player 10s' armor and health are way higher than Eugene's. Yeah, any questions? Cool. So, we have more things to go through actually. For like the last section is arrays. But it doesn't seem we have like any more much time for that. So this is it. If you have time on your own, I would suggest looking at the README if you've never worked with arrays before. If you've worked with arrays before, then really in general, you don't really need to read it. But if you haven't, then I highly recommend you look at the arrays section at the end of the README. But in the case that, we find that we find the need to, we might cover it again in later workshops. But otherwise, thanks for coming. Please make sure to fill out the feedback form. Just to know that you actually get, like, if you fill out the feedback form, we put you in a lottery to win some prizes. And who doesn't want free stuff, right? So yeah, and please let us know how we did. I know there are really weird technical issues today. I saw a lot of you had like split screens and stuff, which is really nice to see that y'all are adapting. Thank you. But also we'll try to get it fixed by next session. Yeah, and so let us know how we did. Did you think the workshop was too short, too long? Thanks for coming. Oh, next week we'll be doing Intro to React. Same time, same place.